Hey guys, today we're going to be talking about some important terminology around relations and functions. And life is all about relationships. The best kind to have are those that are functional. Don't worry, we'll keep it about math today. But some important terms before we get going. An ordered pair is simply an XY coordinate pair that you can plot on the coordinate plane. Now, there are two types of variables that are important to us in algebra. One of them is the independent variable, also known as the input. These are known values in an equation or a function. The other variable is the dependent variable. This is also known as the outputs. Typically is denoted by the y variable, whereas the independent is denoted by the x variable. And these are the variable whose values depend on the input. So typically y depends on the x for a typical function. Okay, so what is a relation? A relation is simply any set of ordered pairs. So take, for example, the ordered pair where your x variable is the number of days in a month to the number of cars produced during that month. Now, you could also have a relation between the time of the day it is and the number of steps you've taken. As the day goes on, the number of steps increases. Or you could also take the relation such as the size of drink you ordered and the number of ounces that come in that cup. So those are just some examples of some relations. How about a function? Well, a function is simply a set of ordered pairs, x and y, in which each first component, typically the x, is paired with exactly one of the second component, y. Now, a little pro tip to kind of spotting that, and a way to think about that, is that no two ordered pairs will have the same first value or the same first input. So take a look at a few of our examples. In our first example there, we see the function has the three sets of ordered pairs, 1, 3, 2, 5, and 3, 0. Since there's no repetition of that first value, x, then we say that that is a function. Similarly, for the second one, we see 1, 3, 2, 3, and 3, 3. Even though our y values repeat, we have a repetition of that second value, it is still a function because the first value does not repeat. And then finally, we see that we have an example of something that is not a function. So this relation, 1, 3, 1, 4, 2, 5, repeats the x value of 1, and therefore it is not a function. Let's take a look at a few examples. And on example number 1 here, we have an isosceles triangle whose has base angles measure of x and a vertex angle, or the third angle, measures of y. Now the relationship can be modeled between these two measures of the angles as y equals 180 minus 2x. We want to know which is the independent and which is the dependent variable. Well, our independent variable is going to be the variable x, or the measure of the base angles. Our dependent variable is going to be y, the vertex angle. And the reason why is because the vertex angle depends on the measure of the base angles. For example, if our base angles both measured 40 degrees, we would double that to get 80 and take that away from 180 to get 100, and that would be the measure of the vertex angle. Likewise, if the base angles were 60 degrees each and we added that up and got 120, then the vertex angle would be the resulting 60 degrees. So the vertex depends on the base angles. Now, in example 2, we are asked to determine if these relations are functions. Remember our pro tip. What we're looking for is repeated first values, or repeated x values. Since there's no repeated x values in example 2, part A, we say yes, it's a function. However, in part B, we see that there is an ordered pair that has a repeated x values. So we have to determine that no, that relation is not a function. And finally, in part C, again, we see all four ordered pairs do not have a repeated value, first value, and therefore, yes, it's a function. All right, moving on, in the next example, let's remember that if a relation is a function, that means that the dependent variable is a function of the independent variable. Now, any ordered pair we list is always listed as the independent variable first, and then the dependent variable second. Therefore, keep in mind, there should be no repeated independent variables in order for it to be a function. So let's take a look at example 3. We're given a data set, and we are asked to determine if we think that y is a function of p. Now, in other words, if I was to write this out as an ordered pair, I would write it as p comma y. P is my independent variable, and y is my dependent. So if I scan my list over here, I see that there is repeated p values. And therefore I have to determine that no, this is not a function because there are repeated values of p. And if I go back over there, I can circle 1993 and 1675, and I see also in 1995 there was a value of 1675. Now the second part of this question flip-flops those two variables and asks, well, is p a function of y? In other words, if I were to write this out as an ordered pair, I would write it out as y comma p. Now y is my independent variable. So if I scan my list of y values, I see that there are no repeated y values. And therefore, because there are no repeated y values, I can determine that yes, p is a function of y. In our next example, we're given the same question. Is y a function of p? So I'm going to write this out as an ordered pair. And again, it goes p comma y. And therefore, I'm looking for repeated values of p, or my percent. I see that I do have some repeated values, so I have to determine that no, p is not that y is not a function of p because there are repeated values of p. I see that 21 repeats and 24 repeats as well. Now again, the second part of this question flip-flops those two variables and asks, is p a function of y? So in other words, y is now my independent variable and p is my dependent variable. So are there any repeated y values? Again, I see that there are no repeated y values here as my years do not repeat, and therefore I can conclude that p is a function of y. Okay, in our final example here, we're given a similar task. We're asked to determine, is height a function of time? So I'll write out my ordered pair as t comma h, and I'm looking for a repeat value in the time. So if I scan that top row there of data points for time, I see that there are no repeated time values, and therefore I can say that yes, height is a function of time. When we flip-flop that around and ask, is time a function of height, I now flip-flop my independent and dependent variables, and I see that I have a repeated value of height, and therefore I can conclude that time is not a function of height. All right, our final example, we're looking at now pay versus hours, and we're given a data set there, and we're asked, is pay a function of the hours worked? So as I write that out, I'll write it out as hours as my independent and pay as my dependent, and I have to conclude that yes, it is a function of hours. When I flip-flop those two variables around, again, I'm going to see that there are no repeated p values there, and therefore that is also a function.